Welcome. This is statistics, so if you're a geometry person, stop watching or suffer confusion. This is your paper for statistics. Make sure you put your name, the date, the period. Today is the 17th, so this would be due 9/19, and don't forget your name. So let's take a look. It says communicate your thinking clearly and completely. Oh, okay. We'll do that. So it says construct a modified boxplot for the data. A modified boxplot just means you put an asterisk for outliers if you believe there is an outlier. And now I can't use my calculator because I wasn't given all the raw data. But let me tell you how to read a Minitab. So a Minitab is a summary that shoots out of computer when you put a bunch of numbers in it. So here this means there were 28 numbers. And if I look at the facts, it says these were test grades from a certain class. So that makes sense. 28 people were in the class. Here's the mean. Here's the median. Confusion, we know what that is. Maybe forget about that. And then they did one better on you. They did a 5-number summary, right? Min, max, quarter 1, quarter 3, and the median is the third number. So min, quarter 1, median, quarter 3, and max, that is a 5-number summary. So 35, quarter 1 was 68, median was 76. These numbers better be in order, least to greatest. Max was 94. Okay, so the highest score, the lowest score, the median score, and the mean. And the mean looks a little left, doesn't it, of the median. So that means that the data is skewed to the left because the mean is to the left. It's enough, and we know that makes sense because somebody got a really low score and it's dragging the median. It's dragging the mean to the left of the median, and that's why it's called left skew. Okay, but let's just make a modified box plot, and we're going to do it with that. Except I got some problems. I don't know if this should be an asterisk or this, and there's actually problems where you have more than one asterisk. So we actually saw a scrap of paper where we know this person got a low score, and then the next lowest score was these guys, and they're actually not that far from the quarter. So I kind of have a hunch that that's probably going to be an asterisk. So you might be thinking, well, how do I know and how do I calculate it? The formula for outlier is just a rule of thumb. So an outlier is calculated using this formula, 1.5 times interquartile range. So now you're like, well, what's the interquartile range? Well, the interquartile range is just quarter 3 minus quarter 1. So that's pretty easy to calculate. You got 84 minus 68, and so you plug in those numbers and you get 16. That's going to be the width of the whole box. The interquartile range is 16. 84 minus 68. Let me just double check my math there. 16. Okay, good. And so an outlier would be something that sticks out beyond the face of the box more than 1.5 times 16. So I'm going to plug in 16 down there. Again, I got that number, and I'm going to plug it in here for IQR. So I get 1.5 times 16, and that's the number 24. So that's how far in front of the box something has to be till I deem that it is, in fact, a outlier. So I make it an asterisk instead of extending the whisker. But, so let's go ahead and do that. So I know the numbers range from 35 all the way up to almost 100. So I'm going to be 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95. Okay. So that's my range of numbers. I know for sure, and I think maybe an asterisk is here, and then my 5 numbers are here, here, and here, and here, and here, except I might stop my whisker sooner if that's an outlier. And that might be an outlier. I don't think it is. That's not very far. So what we have is the median is definitely 76. So that goes right there. Correct? The number in the middle is 76. Quarter 1 is 68. Whoop. Okay, definitely that goes right there. Quarter 3, 84. That goes right there. There it is. There's my box. And if I had to measure it, again, it's supposed to be 16. And it should be, because 84 minus 68 is 16. And now 24 is 1.5 times bigger. I'll do that again. 1.5 times bigger. So that's 24. You got that? Now, I have to put an asterisk if the number 20, if a data point extends 24 beyond that, and it looks like it doesn't. Okay, now I can do that with math. I know the number here. You don't have to put this number, but it's kind of helpful. This was 84. This was 76. This was 68. So to figure out if I have an upper outlier, I take 84 plus 24, and I get 108. So a number that exceeds 108 would be an asterisk, and 94 doesn't exceed it. So since 94 is less than 108, I'm just going to put a regular old whisker there, okay? 94. Now let's check the bottom. So as I check the bottom, I want to do 68. Now I want to see 94 on the other side of that. Excuse me, 24 on the other side of that. So I still have this front of the box. Now the back of the box, I have 68 minus 24. And I get 4. So my whisker is going to extend to 44 if I have the number 44, but I do not. So the next lowest number, and 35 is beyond that. So definitely 35 is supposed to be an asterisk. And I'm going to extend the number to the next lowest number, 57. And I stop there though, because 57 is not lower than 44. So that's going to be my lowest number while I still have a box. Now this number 35 is still my lowest score, but now I've made a modified box plot. And you know why we have our calculator do it, because if we have all 28 numbers, this is what the calculator would graph. And I can't get away without labeling it. So these are student grades. All right. Now it says, write a brief summary. Be sure to say the shape. So it actually looks pretty symmetrical. Without the asterisk, of course. Without the outlier, the left looks symmetrical with the right. All right. The other thing we can say here is we know that whenever the mean is less than the median, data with the outlier is skewed left. So that low score is pulling things over to the left. What else do we know? Okay, so we talked about the shape. Anything unusual, include possible outliers. So the only outlier of a grade of a 35 was found. Okay? No other outliers. The middle 50% of the data. Well, that's kind of sneaky. They're asking you for the middle 50% of the data. So that's the IQR. They're asking for the interquartile range. I'm not even gonna rewrite it, but you should probably rewrite it, is 16. So the middle 50% of the data ranges by, I'll write it, fine. You convinced me. The middle 50% of the data ranges by 16 grade points. Now, I don't know if the grade is in percent, it just says the grade, so the grade points. And last but not least, is there any significance in the difference between the mean and the median? This is kind of interesting. Just by rounding, the mean is 75 and the median is 76. So I think you could actually go back in and say they're fairly close. No, not a significant difference. And again, let's use some common sense here. If kids ask me, so what was the average on the test? I said, oh, the average was about 75. And then somebody else asked and they said, oh, what was the average on that test? And I said, about 76. Is that like really a big difference? I'm not thinking it really is. So I've answered all the pieces of question 11. Thanks for joining us.